I'd like to welcome you to the session here. This is on the Nexus 1000V architecture and deployment. I appreciate you coming out. I know it's late in the day. It's been a long day, but we'll get through this and get out of here. So real quick, this is not I really wouldn't call this an introductory session. If you haven't ever seen the 1000V, it's a very good session. If you've had some exposure, it's still a lot of good information. The idea, what I'm trying to get across is a little bit about what components are in the 1000V, how you deploy them, how you manage them, how they talk to each other, and then what issues that I see a lot in the field when I do deployments, as well as what you'll do kind of day-to-day management, adds, moves, changes, things like that. And so it gives you a really great overview. What I find, and I'm a partner, I'm not with Cisco. I do a lot of deployments of these in the field with different customers in different environments. So what I want to get across is some of these gotchas that I see in a lot of places. And I also run into a lot of people who, they hear about the 1000V, but they don't quite understand how it fits in and what it really looks like in the environment. So when you get out of here today, I hope you have a much better understanding, and you should be able to go back, and if you want to do a deployment, you should have enough knowledge to do that and understand exactly what you're doing and how the pieces talk. So we're going to start off with overview and benefits. I'll run through these fairly quickly. Then we go into the architecture, what makes up the 1000V, some deployment considerations. Then we'll talk about physical connectivity. This is kind of an area that people run into trouble. There's a lot of options here, and sometimes too many options is a bad thing. So we'll talk about how you do that and how you configure that. Then some deployment tips, really things that I've hit in the field that you need to watch out for before you do it. Some configuration examples. These are things that you'll be doing as you deploy. Some of these you'll be doing, every time you want to add a new port group to the VMware cluster. Finally, we'll do troubleshooting. We'll go over probably 90% of what I hit in the field or what I see customers hit in the field when they do their own deployments. So, keep some good notes and keep these things in mind when you start yours. And finally, Q&A. Before we start, just to let everybody know, I have another block of hours tomorrow for one-on-one sessions. I don't remember what time they are. So if I don't get deep enough into something or I don't get a chance to answer a question that you want, feel free to stop by tomorrow right here in Moscone West and just block some time and we can sit down and go over this, go over anything, pretty much anything network related, virtual environment related that you'd like. So starting off in the overview and benefits, the issue we've had really is we virtualize servers. So we've taken these physical servers, we virtualize them, and the VMs themselves have a great view of their resources. They see their storage, they see their networking. They have a great outlook on what they have access to. The problem is when we try to look at things from the network side of the house, it becomes much harder to correlate the data. It's much more difficult to do application monitoring, to do security policies, to do quality of service, now that we've consolidated these. And a lot of that comes from the fact that we have things like DRS, uses vMotion, will move VMs from one place to another. It's very hard to monitor an application if you're not sure 10 minutes from now where that VM might live, therefore you don't know the server, much less what network interface it's going to be sending data out of. It's very hard to apply network policies to locally switch traffic, and by that I mean if you have two VMs, maybe you have a back-end database and a front-end or a mid-tier application server on the same ESX or ESXi host, how do you apply policies to that? They never traverse a separate physical switch, so you really can't apply anything with the standard vSphere switching. You don't really have shared nomenclature for security policies and server administration. The network team is used to doing things in their language and their method. Server admins do it in theirs. And so when we start virtualizing, a lot of that gets mixed up. And that just leads into roles and responsibilities that are changing. The network team used to own the network. Server admins used to manage the servers. And now with virtualization, server admins are kind of moving into the network side, just like they've had to move into the storage side. So they no longer request a port or a VLAN. They have to start doing trunking and think of things like port channeling, how I do load distribution across my network interfaces. So it starts to muddy the waters. So the reason I see most of our customers deploy this, security policies is a major one, especially if you have regulatory compliance, maybe HIPAA, maybe PCI, something like that. They want to do more robust security. They want to put access lists on VMs. They want to do quality of service. They want to do more in depth than what you're capable of doing in vSphere. They want to do network and application monitoring. Maybe they're a NetFlow user right now. When they virtualized this, they've lost some of those capabilities, so they want to gain that back. And in a lot of cases, they want to just give the network administration back to the network team so that the server administrators aren't worrying about it and there's no conflict there. So one of the first questions most people ask when we start talking about the 1000V is what's required? What does it take to do it? Server form factor doesn't matter. The 1000V runs on ESX and runs as a virtual appliance, and we'll get into that in a minute. But form factor doesn't matter. Blades, racks, it doesn't care. All it cares about is it's running on a server that's supported by vSphere, and it sees network interface cards that are also supported by vSphere. So it doesn't run its own NIC drivers, doesn't do anything like that. You don't have to have Cisco physical switches, but it can make things easier. I have a number of customers running this in Nortel shops, HP shops, Brocade Foundry, it doesn't matter. But if you have Cisco switches, you can do things with CDP, which is Cisco Discovery Protocol, that allow you to do some things automatically. Also, if you call VMware for support and they have to escalate an issue to Cisco TAC, and Cisco TAC needs to look at the up layer physical switch, do you think they know Cisco switches better than they know Nortel switches? I'm sure they do. But I'm sure they have people that know Nortel switches, but they're probably going to have to bring yet another person on the line. So it just kind of smooths some things out. But again, I've got customers running all sorts of switching gear. 1 gig NICs, 10 gig NICs, it doesn't matter. As long as ESX supports it, you're fine. And it runs on both ESX and ESXi as long as you have Enterprise Plus licensing. And you do have to have Plus licensing. And just FYI, this is licensed by socket of the vSphere host. So the management modules we'll talk about in a minute, you don't license, you just license the number of vSphere hosts you have in your cluster that you want to use this with. And it is an additional license above and beyond the Enterprise Plus. So real quick talk about architecture. If you've ever worked with a Cisco chassis switch, say a Catalyst 6500, maybe a 4500, the Nexus 1000V makes a lot of sense. It looks very much like a 66-slot Cisco chassis switch. There's separate control and data planes with similar redundancies and failover as a physical switch. Much like these, if the management or control plane fails, you don't lose access to any of your VMs, no traffic stops, data flow doesn't stop. And it does have redundancy in management. You have a primary and a secondary. The components that make these parts up, you really have two things that you have to deploy when you deploy the 1000V. The first thing you need to deploy is what's called the Virtual Supervisor Module, the VSM. The VSM is the control plane. It's what manages everything. It's what manages the switch. It's what you do to make administrative changes. It leverages NXOS, which is an evolution of iOS and SAN-OS from Cisco. It's called Nexus OS. It's just a new generation. If you're familiar with iOS, you'll feel right at home. It's iOS with a bunch of neat features that's nice to have. And you can control multiple virtual Ethernet modules with one set of virtual supervisor modules. The virtual Ethernet module is what's get installed on each of your vSphere hosts. It's a little piece of software, gets installed, and it coexists along, I say replaces here, but really it coexists with VMware's virtual switch because you can run the existing standard switch along with the 1000V on the same host. The virtual Ethernet module runs on the ESX host. It enables advanced switching, and we'll get into how it provides each VM with dedicated switch ports. But just keep in mind there's two pieces, there's two components. It's not overly complicated. You have your control plane in the VSM, your data plane in the virtual Ethernet module. The virtual Ethernet module is what you license. Since if it goes on 10 ESX hosts, they have 2 sockets of processors each, you would buy 20 licenses. You do not license the virtual supervisor modules. The VSMs get deployed 2 different ways. The most common way is they're deployed as a virtual appliance that runs under vSphere in a cluster. They can be deployed via an OVA file with a GUI. They can be deployed with an OVF file, just kind of import them as a virtual machine. But they can manage up to 64 VEMs. So they can manage up to 64 hosts with one set of these supervisor modules. So you have 64 hosts, 2 supervisor modules, so it's kind of like having 66 slots in a switch. Normally you deploy these in pairs. Why? For redundancy and failover. You have an active, and you have a secondary or an HA failover, they are not active-active. One of them is running as primary, one of them is running as secondary. If the primary fails, the secondary reboots and takes over. There's no reason not to run two of these. They are very low utilization. They use 3 gigs of space on a data store. No reason not to have two. The other option is the new Nexus 1010 physical appliance. You can see that down on the expo floor. The nice thing about the physical appliance is there's a lot of network teams that kind of have their network gear on one side of the data center and all of the, the rest of the stuff it manages on the other side of the data center. And they just like to have that physical piece of equipment under their control. Some people also like it because you don't have a management device living in a cluster that it's managing. So for people that, I run into this a lot with vCenter. We don't want to virtualize vCenter because we don't want vCenter managing what it lives in, and they do the same thing with the VSMs. A benefit of the 1010 is that if you have a lot of hosts, or if you have a DMZ network and a production network and you want to do 2 implementations of this switch with different security policies and management, each 1010 physical appliance can run 4 VSM modules or VSM appliances in there. So you normally run those as pairs as well for failover, but you can have up to basically 4 instances of that switch with 2 pairs of appliances. So it does let you scale out very easily. To give you kind of a look of what the switch looks like, to kind of bring it back and show you what it looks like on the ground, everything is done via command line, just like a Cisco switch. So you'll SSH, you'll PuTTY into it, Telnet to it, and you run NXOS commands. All changes, all updates are done through this interface, just like a Cisco switch. You will get information in vCenter, but you're not allowed to make changes in vCenter. You can't create a port group in vCenter on the Nexus 1000V. It is read-only. It displays back information, and that's it. So this is the first command that I run. This is a show module command. And what you'll see here is the supervisor is a module, so you have one active and one standby. And then each ESX host looks like a module. Since he has that virtual Ethernet module loaded, he looks like a module in a chassis switch. In this case, we have 18 hosts in this cluster, and so you'll have 1 and 2 are always a supervisor, and then 3 down will be your ESX hosts. The next, if I would hit spacebar and scroll down into this PuTTY session, this kind of lays out that module 1 and module 2 are the soups, and you'll see that module 3 is, pointer works, there it goes. Module 3 is ESX server 02. And they're assigned module numbers as you roll them into the switch. So for some reason we did 2 first, then 1, then 4, and on. So it's kind of nice to know that ESX02 is module 3, and there's his IP address. That's for the service console. I can do show interfaces. If you've ever used a Cisco switch and you do a show interface, you can pull up statistics, counters, configurations, kind of the health of the interface. I'll give you a little bit of a hint with this when you look at it. Anytime you're in the Nexus 1000V and you do anything Ethernet, show interface, Ethernet 3.5, Ethernet means physical. So right here, I am looking at a physical NIC. This is NIC 5. If you look, how vSphere numbers its NICs. This server had an internal 4-port card and then 2 10 gig cards. This is the first 10 gig, so it went, 0, 1, 2, 3, 4, and then here's one of the first 10 gigs. This is module 3. VM NIC 5. So a minute ago, we saw that module 3 is ESX02. So this is a physical uplink port on the back of ESX02. You look, it's 10 gig. You can see it's 10 gig right here, just like it shows on a normal switch. Full duplex, 10 gig, and it shows all the counters. So you'll be able to track counters, track flow. If you use SolarWinds Orion toolset, you can point it to this and watch it just like an interface for errors, problems, counter statistics, anything like that. Here's where you get the real feature set of what you want and why you deploy this. So here I'm doing a show interface on vEthernet, virtual Ethernet. Anything with vEthernet is a virtual machine's network card. So if we look, this is vEthernet 14, and it gives you the name of the virtual machine. In this case, it's CHV HPFA. And it's network adapter 1, so it's the first NIC on that VM. He was assigned Ethernet 14 because that's the 14th NIC on a virtual machine. The beauty of this is he will always be virtual Ethernet 14. I don't care where DRS floats him in the cluster. I don't care if I shut him down and reboot him or do whatever I do. He'll always be 14. So the benefit of that is if I want to do an access control list against him, I do one against VHNet 14. If I want to monitor packet flow or frame flow and I do a packet sniffer, I can point it to Ethernet 14, and I don't care if DRS moves it from ESX02 to ESX18, my packet sniffer doesn't stop because the switch worries about where he lands. All of your counter statistics, again, you can use something like Orion, if my pointer would work, and these statistics don't reset. They don't stop, every time it doesn't reset, doesn't clear them every time it vMotions. So you can get constant trending and data statistics on this for as long as this NIC is up and running. The other thing you'll see here is it's got port profile. The 1000V calls them profiles. When they get converted to vCenter, we know them as port groups. I'm descriptive on my naming, so this is VM servers, VLAN 400. So I know he's on VLAN 400. This is what it looks like from vCenter. To vCenter, it looks like the standard VMware DV switch. The only problem again is you can't create port groups or anything. If you haven't seen the standard DV switch interface, it's pretty simple. On the right side, these are physical NICs. It has a whole bunch of them, even though it doesn't have that many NICs in the server, but it just shows VMNIC 4, VMNIC 5, and on the left side, it shows all the port groups that he knows about. So if we look, VM servers 400 right there, that's the one that VMNIC was a part of. So the server administrator will get access and be able to see the configuration, see the output, and be able to assign virtual machines to these port groups, but the port groups have to be created on the 1000V, and then the configuration gets replicated to vCenter. But it is a switch. So a lot of network guys are like, but is it really a switch? I mean, I know it looks like a switch. And the answer to that is yes. It's a switch, much like the internal ESX switch is a switch. It's a switch in software. It forwards frames based on MAC address, learning, CAM tables, and things like that. The nice thing is it's much simpler than a physical switch because it knows that there's nothing chained off of it. The big problem with switches in a data center is what happens if the next guy comes in and plugs another switch into it, and then somebody plugs a switch into that, and I create a loop. So I have to worry about that. Network administrators stay up at night worrying about that. With this, I know there's no way to do that, so he doesn't have to do things like run spanning tree to detect loops, so it's a much simpler configuration. He also can do things where he doesn't have to create port channels to do upstream, multiple connections upstream. It's much like the standard VMware vSwitch. You add 4 NICs into a vSwitch, you set them all to active, you set your load distribution type, hash by virtual port ID by default, and that's not really a port channel. You can do the same things here so you don't have to do complicated configurations. Again, there's no spanning tree. It does things to stop loops. BPDUs are kind of detection packets or detection frames that spanning tree uses to find loops in the network and work out different scenarios. If it sees one of those from a switch, it drops it. He doesn't participate, he doesn't play that game, so he has no need for those. If he receives a frame from the switch, he gets it and looks at it and says, I don't own this MAC address. This doesn't belong to me. He doesn't re-forward it out another NIC because that would create a loop in the network. He drops it. If he sends a frame out one of his interfaces destined for the external network and for some reason he sees it come back in on the other side, that's called a deja vu check. He's seen this frame before. He's not going to pass it again. He's going to drop it. So there's no loops in this and no worries about spanning tree. But it does switch frames. A lot of people ask me, every time I send out a frame or I do, one VM talks to another VM on the same host, do I bounce off of that VSM? Does it send it over to the supervisor module to be forwarded? And the answer to that is no. There's no reason to do that. It would cause, an amazing amount of constraint. So if VM1 and VM2 are sitting on the same ESX host and they want to talk, it's switched internally just like it is now. He doesn't learn MAC addresses to the outside world. He doesn't have to. He knows about his virtual machines. If a frame shows up and it doesn't belong to one of the VMs he's responsible for, he sends it off to the rest of the network. Broadcasts are sent both internally and then externally through a single uplink, again, not to duplicate frames. But just keep that in mind. The VSM is management. You can shut them down, take them offline, power them off. and data flow doesn't stop. Packets or frames still go in and out of the cluster. VMs are still talking fine. You just can't make changes to the switch. An administrator couldn't boot a new VM because there's no management console to assign a vEthernet interface to it. So the management VSMs are not required for switch functionality, but you're kind of in a holding pattern until those come back up again, and that's why you run redundant pairs. The key to the configuration of this is you deploy your VSMs through a Nexus 1010 or through the virtual appliances that live in the cluster. You deploy your virtual Ethernet modules, you install those on each of the hosts, but they have to talk to each other. And this is what gets people all the time on configuration. It sounds simple, but 90% of the time, this is where the problem is. So those two things talk to each other over two channels. One's called a control interface, one's called a packet interface. Control interface is your standard control information, synchronizing configurations, doing keep alives, are you there, yeah, I'm here. It has a 2-second heartbeat. After 6 seconds, it considers it lost and that module drops out of the switch. It also maintains synchronization between the primary and the secondary VSM. So when the secondary comes up, he sends a flood out on the control interface looking for the other one. If the primary's there, he answers them, they sync config, everybody's happy. The packet interface is for other things. Cisco Discovery Protocol, IGMP snooping for multicasting. If you're doing a packet sniffer, it's called SPAN or RSPAN in Cisco. If you're doing a packet sniffer, it goes over this interface. It's very simple. They're just two VLANs. So you have a control VLAN and a packet VLAN. There's no IP addressing on it. It's all layer 2, so you don't have to go get a range of IPs. But if these two interfaces, and I'll talk about this more in a minute, aren't trunked properly, this doesn't work, and that's normally what happens. So the management packet and control VLANs, and the management is nothing but my SSH or Telnet interface, but the packet and control VLANs can use the same, control interfaces can use the same VLAN. This is now a Cisco best practice. Originally it was you need to assign 2 VLANs, one for each. Now they say don't worry about it. I say VLANs are free and they're normally not constrained outside of some service providers. So if you can assign 2, I assign 2. That way if I'm doing a big span and I'm doing a lot of packet sniffing, I'm not going to flood the control VLAN with too much traffic. They need to be trunked end to end. So all the ESX hosts with the VMs installed, these VLANs need to be trunked down to them. They need to be trunked back to the VSMs. If they're on an appliance, as long as all the ESX hosts have access, they're good. If it's to a 1010, you need to trunk them over there. This is the number one cause of problems. Again, I'm a partner. This is the first thing I ask customers to do when we come on site to do an install, and either intentionally or unintentionally customers will lie to you. But a lot of times it's not, they'll trunk them down, but they don't trunk them between aggregation switches or something like that. You don't need to worry about trunking these all over the network, up to the core, anything like that. It just needs to be done within the ESX environment. So just keep that in mind. If your primary and secondary VSMs aren't talking, or you install the VEM on your first host and you're all excited, but it never shows up as a module, this is the problem. I guarantee it. There is an option to do layer 3 with IP addressing. I don't have anybody using this yet, but if for some reason you have a Nexus 1010 appliance over here and your ESX hosts are on the other side of a data center and you have to go through a router to get there, you haven't extended the VLANs across, then you can use layer 3 and assign IPs and do everything that way. I don't have anybody using this, but we're starting to see more and more interest in it. But it is an option. That's a fairly new option that's appeared in later versions of the switch. Some best practices. In the initial versions of this, if I run the VSMs as appliances in my cluster, I couldn't run the control and packet interfaces over the distributed switch. So I had to have 1 or 2 NICs still on the old vSwitch, and all the rest of my interfaces could run over the distributed switch. That was a little bit messy for a lot of people. With current versions, you can just roll everything in. That used to be an even bigger issue if you only had 2 10 gig interfaces in a server. I can't really split that out. That's no longer a problem. That was resolved in what we call Release 1 or Version 1 Service Release 2. The latest version is 1.3a. I've talked to a few people who don't like to run the latest and greatest code from Cisco or other people. They like to be one version back. This is not the product to do that, okay? I don't mean it in a bad way, but there were a lot of bugs in 1.1. We hit a couple of nasty ones in 1.2, and 1.3a has been very good to us. So run 1.3a. Trust me on that. Or you're going to call Cisco, and they're going to look, and the first thing they're going to do is say upgrade to 1.3a. Just save yourself the trouble and do it. There should always be 2 VSMs deployed. I mean, again, they're not licensed. They don't cost you money to deploy 2 of them. So just do it. Put them on separate data stores. Put them on separate hosts. Again, they use 3 gig on a data store each. And I think the CPU reservation on the virtual appliance is like 1,500 megahertz. So it's not a lot. If you do a Nexus 1010, buy 2 of them. They're not cheap. Don't be fooled by the fact that one appliance can run 4 VSMs, so you can pair 2 of them. If it goes down and you're out for 4 hours waiting on a new unit from Cisco, you might run into a problem, so don't do that. So some considerations. A couple of these things kind of seem obvious, but I hit them all the time. First of all, if you're a big Nortel shop and nobody in the whole place knows Cisco IOS, there's a learning curve there. It's not a huge learning curve, but it's still, you're going to have to learn this and treat this as a different environment. So keep that in mind. A lot of small shops bring this in with people without much network experience. It's a huge learning curve for that. But if you do have Cisco IOS experience in-house, the new Nexus OS is very similar. I'm an old iOS guy. I have no problem using Nexus OS. There's 1 or 2 commands that they've deprecated, but everything else is just fine. So don't worry about that. But there is, you do need some Cisco knowledge. I run into VMware clusters all the time to where they plug the NICs into the switches, and the switches are access ports. So they're not doing any trunking. They're not doing any VLAN tagging. You got to do VLAN tagging for this. It's a switch. It trunks. It has, control interface, packet interface, plus some other things. So if you're not trunking to your host now, it's time to start. Plus, it's going to save you a lot of trouble later when you decide to split fault tolerance off or something like that. So just go ahead and get it over with and do it. But just, stop doing access ports to the ESX host. Other one I've hit this once or twice. You see this a lot pretty much with people who have a DMZ network. So they have a DMZ set of switches that are physically separate from production set of switches. But for whatever reason, the person that set them up used VLAN 1 on both of them. I've hit it. And so what happens is you have to remember, the standard vSwitch will let you do things that are not a great idea. But it works because VMware vSphere doesn't, those 2 vSwitches don't commingle with each other. This is a distributed virtual switch. It's one switch across your whole cluster. So if these NICs go to my DMZ network and they're tagging VLAN 1, and these NICs go to my production network and they're tagging VLAN 1, and a frame shows up on the 1000V and says, I need to go to VLAN 1. Which one's the right one? It doesn't know. Sometimes it works. Sometimes it doesn't. It just all depends on which NICs or which port groups he happens to choose. So you'll run into quirky issues, and I'll see people who have overlapping VLANs, and I'm like, there's your problem. It assumes if there's 2 connections to VLAN 1, that's all the same happy network. So don't do this. If you're doing this, fix it. If you're using VLAN 1 for actual data flow, stop doing that too. Physical connectivity. This is the one that kind of confuses people. Creating port groups is easy. Physical connectivity, it takes a minute to wrap your head around it. So with the normal VMware vSwitch, you assign multiple NICs to a vSwitch, you kind of set them active, passive, and you figure out how you want to do distribution. And there's some great documentation on, do I do IP hashing, MAC hashing, virtual ID hashing, anything like that. It all depends on how many different switches and what kind you're connecting to. With the 1000V, you've got options. You can do MAC pinning, which is basically this VM goes up one interface, the next VM goes up the other interface. You can do LACP, which is kind of dynamic port channels. Manual configuration, where you lay all this out yourself and nobody wants to do that. And a common one is what we call virtual port channel host mode. And we'll talk about that one here in a minute. That kind of gives you the in-between of the best performance with easy manageability. So, it used to be you had one NIC connected to a server, everything off of that, the server knew any frame it got, didn't matter what the MAC address was, it only had one way to send it, so it sent it up and it got its replies back. There were no chances of loops. But then we started adding multiple connections, so we got one server with 4 connections to 2 different switches because we want to be redundant, but we need more performance. The problem is if you don't do port channels, you really only get, a VM can only send data up and back through one interface connection. So you get a VM that can take advantage of a single gigabit NIC, and each time it just starts round robining throughout. If we tried to do that, the switch is going to start saying, wait a minute, I see the MAC address here. Now I see it here. Back and forth, and you're going to start getting MAC flapping. So we create port channels. Port channels like the host see 2 connections as one logical connection, and the switch sees 2 connections as one logical. So those 2 interfaces look like one logical, and he can send multiple frames down those for better throughput. The best way to do it is if you're, say, a Cisco Catalyst 6500 user or a new Nexus 5000 or 7000 from Cisco. Nortel also has this option on some of their switches. I can take 2 separate switches, link them together, and to a host they look like one switch. I manage them that way. So I can run redundant connections to those 2 switches, and the host doesn't have to worry about where he sends traffic. The switches up level worry about keeping MAC address synchronizations. So I get great throughput, high redundancy, high reliability, very simple configuration. If you're a 6500 customer with a supervisor that supports this, fantastic. Most people don't have that. So what do you do if you don't have that? You do what we call VPC host mode. This is a bit more complicated on the configuration, but it kind of breaks down fairly simple. The way the server sees it is if I have 4 NICs to 2 separate switches, and those switches don't talk to each other, it creates a port channel to one switch, a port channel to the other switch, and then it just load balances back and forth between those 2 connections. So half my VMs will go left, half my VMs will go right, but all the VMs that go left get equally distributed across those 2 connections, and all the VMs that go right get equally distributed. So I don't get to distribute across everything, but it's a whole lot better than just round robin 1, 2, 3, 4. It's very easy to set up. The nice, this is one of the areas where it's kind of nice to have Cisco switches upstream because it's all automatic. I type in a command, the Nexus talks to the upstream switch, Cisco switch over the discovery protocol, and it says, oh, your name is switch 0, and I've got 2 connections to you, and your name is switch 1, and I've got 2 connections to you, and he figures the rest out on his own. If you don't have Cisco upstream, you have to manually say these 2 go to one and these 2 go to the other. You do that one time and you're done. You don't have to keep constantly updating it. But Cisco switches do make this easier. If you don't want to deal with any of that, you can just do what we call MAC pinning. MAC pinning is very simple. This VM's traffic goes up the first interface. The second VM goes up the second, third up the third, and it just keeps rotating through the interfaces. This is now the Cisco current best practice. Now you're going to say, this doesn't have nearly as much performance as the last option, so why is it best practice? It keeps you from calling Cisco TAC. It works no matter what. So I don't care if you've got 8 switches up there, 2 are from Netgear, 3 are from D-Link, and 3 are from Nortel. He doesn't care because he's not having to talk to them, he's not having to bundle them. It just works. So this is an option that we see a lot of people use as long as they're not needing heavy throughput to a single VM or something like that. I see people do this a lot, and for probably 90% of users out there, it works great. But if you want better performance, then you really have to go back to something like port channeling. A couple of things to do when you do your deployments. First thing you need to do is create those 2 VLANs or 1 VLAN if you're going to share them. And they only need to exist between the ESX host and the VSM, like I mentioned. And at the bottom, what I normally do with like an ESX environment is I'll create a service console on one, I'll create a service console on the other one, I'll have them tagged for the VLANs for the control and the packet, and I'll ping across them. Why do I do that? Because it confirms connectivity. Did the network guy really do what he told me he did? If I've got switches and I have to go through aggregation switches, did he really trunk them between the 2 aggregation switches? A lot of times, this will save you hours of troubleshooting when they swear something's done. This is really useful in a blade environment. So if you've got I'll pick on HP C7000 with switches in the chassis, HP will say, those aren't switches. Well, you still have to create VLANs in them and tell it which VLANs to pass. People forget to do that all the time. The network guy will trunk down the VLAN to the chassis. Server guy will forget to trunk them down inside the internal blades, and then they don't pass. But if I create a service console or a temporary VM on each one and just put them in a port group that's tagging to that VLAN and ping across, I'll know real fast whether that works or not. So it's just my hint, my tip. This is a great way to make sure those VLANs work before you take somebody's word. Here's something that we used to do a lot when the 1000V first came out, and I mentioned that we had some issues. So the problem was, what about things like service console? So this is a distributed switch. You might be, say you're new to the Cisco environment. Let's say you decide, you know what, I've got two 10 gig connections to each switch, so we got to run everything over this, and we got to run everything through the distributed switch. So you run service consoles, vMotion, fault tolerance, and VMs through it. Somebody comes in there and clears the config out in the 1000V. What happens? You just lost all connectivity to all your ESX hosts. And let me tell you, it's a lot easier to rebuild that host than it is to try to fix that from the command line. So we used to do a lot of things where we would keep two 1 gig connections out for the service console and then run everything else, all the rest of the NICs through the distributed switch, assign them over there. I don't do this really anymore by default unless a customer is a little bit shaky on if they want to do it. You can always, roll everything over later. We don't do it nearly as much as we used to, but we call it a lifeline, and we still see it done on some occasions. So just kind of, this might be a migration strategy for you if you're a little bit unsure that you want to take on everything, because you can drop connectivity to the whole cluster with a bad configuration. Cisco actually used to recommend this in 1.2. They would say, keep service console out of the switch. And now you call them and, no, put everything over there. So even they've got more comfortable doing it. I talked about deploying the VSM early. You could deploy it a couple of ways. This is for the virtual appliance edition, not the physical piece of hardware. You basically can deploy via OVF, which is just a file that imports in and dumps a VM on a data store, or an OVA. An OVA is a wrapper around an OVF file. So it still dumps a VM on a data store, but then it walks you through a nice GUI to kind of set some of the initial configurations. They did this on version 1.2 because the way this works is normally a VMware admin deploys these appliances, and they would install it, they would boot it, and then it starts walking them through a Cisco setup wizard. If you've ever used a Cisco switch, it's that same basic setup to get management running. Well, they didn't know how to answer the questions. They'd never seen that before, so it caused problems. So they made an OVA file, and they put a GUI around it. The problem is the GUI will ask you the same question twice in two different places. It'll ask you like IP addressing twice, passwords twice. So what's everybody think? I messed something up. I don't know what I'm doing. No, it just asks you things twice. So if you do the GUI and you see the same questions twice, you're okay. That's normal. The secondary VSM that's going to act as the failover, don't worry about doing the GUI with that. You're going to waste your time. You're going to answer all those questions again, and none of it matters. So you deploy the second one as a standard OVA or OVF file, boot it up, and it's going to ask you three questions. One, what's my domain ID? A domain ID is just a number in case you deploy multiple 1000Vs in your network. Most people enter 1. So my domain ID is 1. What's my control VLAN? You give it that. And then am I primary, a secondary, or a standalone? Well, you're a secondary. Okay, thanks. And it reboots, talks to the primary, and pulls the config, and you're done. It's very quick, so there's no reason to walk through the GUI and just get confused twice. The VEM is simple to deploy. You can do it through Update Manager. You can just add the Cisco repository to Update Manager, and when you go into the network config in vCenter and say, I want to move this guy over to the distributed switch, it will push the VEM down to it and install it. Sometimes Update Manager lags. When I did my first 1.3a install, it was 2 weeks after 1.3a came out. 1.3a VEM was not up on the repository yet, so we had to do manual installations. So you can do that with the remote tools on ESXi. You can do it locally with the ESX update on an ESX server. It's kind of up to you, but you can do VUM or you can just do manually. Going forward, once you do install it, all the updates are done via Update Manager. So VUM will update it. You add the repository. As patches come out, it'll handle doing the updates, putting in the host in maintenance mode. A couple of commands. The one here is if you do a manual install, I have a VEM status command that you can run just to make sure it's running. Doesn't mean it's configured correctly, just means the driver's installed and it hasn't crashed. You can do multiple implementations. Some people do it like a DMZ network and a production network. They may do it because they have more than 64 hosts. You may have 200 ESX hosts in a big environment and one install can't do it. So we see a lot of people doing Nexus 1010s for that because, again, 4 VSM instances and one piece of gear, and they'll do it for that reason. But again, there's no reason you can't do it. They don't overlap. They don't cause a problem. Some examples. Like I said, and I've said like 20 times, if you're familiar with Cisco switches, this is going to look real familiar. So I'll give you a couple of little configuration options here. The first one is a physical connection. So you deployed your VSM. He's running primary and secondary. You deployed your VEMs to all the hosts. You're feeling pretty good. Everything's just fine. So the first thing you normally have to do is start configuring your physical connectivity to the host. Because before you do this, you can't move an ESX host to the switch. So the command walkthrough is this. Port profile, and we'll say type Ethernet. Remember what I said earlier? Ethernet means physical, so we're doing a physical configuration. Type Ethernet, and the name of this profile is System Uplink. System Uplink sounds official. It sounds like that's a command. It's not. I could call it Jason's Physical Uplink if I wanted to. VMware port group is just a command to say that we're going to send this up to the vCenter database. Switch port mode trunk. That's a normal Cisco switch command. Okay? We use trunk when we're talking about the physical connectivity because we're trunking multiple VLANs down. And then we're going to say which VLANs do we allow to ride over this trunk. In this case, I'm letting all of them go. In this instance, in this configuration, this was a server with 2 10 gig connections. So we just did one uplink and we're using it for that. Let's say I had 8 uplinks and I wanted to use 2 for vMotion and I wanted to use 2 for virtual machine traffic. I may have a type Ethernet port profile, one called vMotion uplink and one called VM traffic uplink, and then I want to tell it which VLANs I want to allow. Why don't I just say VLAN all on both of them? Because the switch doesn't know where to send traffic to. So spread those out and segment them properly. The next long command is channel group auto. This is how you tell it to port channel multiple interfaces. So channel group auto means do this for me automatically, mode on, turn it on, and subgroup CDP is virtual port channel host mode because I'm talking to Cisco switches and they can do CDP. So this is where you can say I want to do MAC pinning, I want to do VPC host mode, I want to do LACP. You can check the Cisco documentation for your use case and figure out which one you want to use. No shutdown is a normal Cisco command. Bring the interface up. And then I have this system VLAN command. This is an important command. This bites a lot of people. This is the second thing they hit once they finally get their VLANs configured and trunked. So let's say that an ESX host has just come online and it needs to do things like talk to the virtual supervisor module. Well, how do I talk to the virtual supervisor module? The switch isn't up yet. And I can't get the switch up until I talk to the VSM, so I have a chicken and egg problem. System VLAN means anything destined for VLAN 401, 403, or 404, I'm going to send whether that switch is up or not. So when you roll an ESX host into the distributed switch, vCenter sends it some information. It's called opaque information or opaque data. It basically says, from this point forward, anything destined to these VLANs, send them no matter what. So the things that you want to do this for are control VLAN, packet VLAN, management, vMotion, iSCSI, and NFS, because those are things you don't want to stop working for any reason. So if there's a hiccup in the switch, I don't want my NFS traffic to stop. So those are the primary ones you want to remember. And then the final command is state enabled. When you type state enabled, you're going to see a task kick off in vCenter console, and you're going to see these things get updated into the network database. So this is your physical connectivity. Then you say, server administrator calls and says, I need some new port groups. I need VLAN 400. Okay, so the network guy will log in. He does a new port profile, but this time it's type vEthernet. This means it's going to be a VMware port group. Give it a name. We use the port group command again. The third command, max ports. By default, the max ports on a new port group is 32. That means if you bring up 33 new VMs with 1 NIC each, that 33rd VM is out of luck. People hit this limit real fast. So normally I go ahead and raise that to 256 or 512 right off the bat. So if you do this and you deploy it and you forget to do this and you bring up that new VM, you're going to get an error when you try to power it on. And it's not hard to figure it out, but you wonder why they set it to 32. Unlike the other ones where it was switch port mode trunk, these is an access port, meaning this is a single VLAN, and anything that hits this, I'm going to tag it with VLAN 400. So I do switch port mode access, just like a physical switch, and I'm going to say you want to tag everything with switch port access on VLAN 400, so he tags that. And then we do a no shut and a state enabled. The last one I point out for a very specific reason. This is, we're creating a new port group called management, and it's VLAN 401. But notice I do a system VLAN there. You have to do system VLAN in 2 places. This is what bites everybody. They're very diligent. When they create the physical uplink profile, they put them all there. But then when they create these new port groups, they forget to do it, and it doesn't work. If you put it in one place but not the other, it's like you didn't do it at all. So again, management, packet, control, NFS, iSCSI, and vMotion. So if you have a vMotion port group, you need to do system VLAN there. There's no downside to doing system VLAN. I have customers that do system VLAN for everything. Really the only negative to it is I can't do no system VLAN and get rid of that until I have no virtual machine NICs or ESX VM kernel NICs in that port group. I have to pull them all out, and then I can remove that command. So it's very easy to add things into system VLAN. It can be harder to take them out. And the final piece of the config is how you connect to vCenter. Domain ID, remember I said it increments. If you have 5 instances of it, you'll all be different. You tell it the control and packet VLANs. The mode is layer 2, not layer 3. And then finally, it's just remote IP address. And then the end connect. Most of this, if you use the GUI, is all done for you. But you do a show config, you'll see it. But all of this is actually typed in for you if you do the GUI. But you do point it to vCenter to update the configurations. Quick on the troubleshooting. First thing is, let's say you create a new port group, or you go in, you create a new port group, it never shows up in vCenter. First thing you want to check is status is connected, sync status is complete. If this is disconnected or this is not complete, you probably want to go back into this piece of the command and retype connect. So if for some reason the VSM drops connectivity, you reboot Virtual Center, right? It can't connect. It'll automatically keep trying and reconnect. But what if you take down vCenter for 4 hours? Eventually it's going to give up. So you're going to need to go back in here and say connect. That's an easy one. If for some reason it can't connect, try to ping the vCenter IP address from the console. If you can't ping it, then it's probably that management interface that's not right. If a VEM isn't talking, a module goes offline, you can run the VEM restart and the VEM reload commands on the host or remotely through ESXi. This just kicks the driver again and says restart. I haven't seen a VEM crash since like 1.1, but you have the options there. The biggest issue, again, I've said it, I know 10 times, is the control and packet VLANs aren't trunked properly. One of the first things people see when you add a new host to the switch and you'll do a show log, you'll see this command in the log. Host blah, blah, blah is added to the distributed virtual switch. The host is not found as a module in the configuration. This is normal. First time you add a host, it's not in the configuration. But what the problem is, you'll see this, but 10 minutes will go by and you'll type a show module like I showed you early in the presentation, and it still doesn't show up as a module. This means it talked to vCenter, but it's not talking to the VSM. So again, that's your control VLAN. If you bring up your 2 VSMs and you don't see this, what you want to see is active with HA standby. That means I'm the primary and I see my secondary. But what if you boot up both of them and both of them say active with no standby? That means they're not talking. The control VLAN isn't trunked properly. I bet you if you shut one down, move it over so they're on the same host and boot them on the same host, they'll work because they're talking internal to each other. But as soon as you move it to another host, they stop working. That means your control VLAN's not trunked properly. A couple of other really quick things. If you're having crazy issues, you can check up level and make sure that the physical switches see the MAC addresses. If in doubt, reboot the VSM. I've seen weird things happen where updates don't get sent. If you reboot the VSM, it fixes it. Again, rebooting VSM does not stop traffic flow. Cisco has an awesome flowchart troubleshooting document now. Try this. If you see this, do that. If you don't, do this. It's like one of those old choose your own adventure books you had when you were kids. If you have to call VMware, and you have to call VMware because VMware is the first line of support for the 1000V, a year ago they weren't great at supporting the 1000V. They've gotten a lot better. But if after you're not getting any traction or you're not getting any movement after 10 or 15 minutes, say the magic words. I'd like to escalate this to Cisco TAC, please. And then they'll get Cisco TAC on the line, and Cisco TAC knows what they're doing. Also, shoot me an email. I'll have my contact info up in a second. Louis Wada from Cisco did an amazing troubleshooting presentation at Cisco Live. The new 1.3a has some really nice features for troubleshooting that were not in earlier versions. I'm happy to send that to you. I've got about 100 people I'm sending it to tonight. So give me your email address and I'll do that. Finally, what happens if I delete my VSM and I can't get to the switch? I have a link to my blog at the end as well. I did a write-up on how you can basically recover an orphan switch. It takes like 3 minutes. It's not a big deal. If you're smart, you've backed up your configuration at some point, and it makes it a lot easier. And that's it. There's my contact information. I do a lot of blogging on the 1KV and Nexus lines from Cisco, so feel free to read. Shoot me an email, jason@vero.com. And if you have any questions, I'll stick around here and eventually go out.